welcome to another stream of this illus2D game engine series that we're making a game engine using Scratch, using C++ and OpenGL. Okay, so in this stream we're going to be tackling on textures. Okay, textures are really fun, of course. I hope you know what texture is. It's like texture is just like a image on top of a shape or something like that. That's basically what a texture is. Okay. Now, if you run the program, see from the previous episodes, we had this. We had a lovely rotating kind of this triangle thing which rotates with time. We had this FPS counter here, which is really cool, and yeah, that's basically what we had. Now, this video we're going to be getting into textures. Textures are going to be really fun because since we're doing it from a low level, like C++ and OpenGL is definitely low level. That's why we're doing it. We need a way to load textures. Now, textures are basically, if you kind of think about it, textures are just an array of RGB pixels. Okay, so if, for example, I'll open an image right here. I'll open my logo that I made. So this is my logo. Okay. So a texture, what texture really is a texture is just a collection of RGB pixels. Now, see, now this texture has all these pixels. It takes all these pixels, and if I zoom into a pixel right here, I really I cannot zoom any more than this. But if I could really zoom in and see like an individual pixel, basically what the pixel has, it has RGBA values. It has a red value, it has a green value, it has blue value, and an A, which is an alpha transparency thing. So it has 4 values which is stored into the memory. Okay, so textures are basically an array of RGBA values. That's basically what a texture is, and our monitor gets those values from the RAM and it kind of displays it. That's how anything displaying. That's how the monitor. That's how it works. Okay, so we need a way. So basically, what I want to say is that we need a way to load textures, and we need, more specifically, we need an image loader. Now, we could write our own image loader if we had like a lot of time. If we had months of free time, we could write our own image loader. But we don't have that much time. We're just trying to make a simple game engine. So what we're going to do is we're going to be using a image loader, a open source image loader from GitHub. So the name of this image loader is STBI image. It's the most popular one. So if you just go to STB image, so if you just go to Google and search for STB image, just click on the first GitHub link, and you can download this thing right here. So stbimage.h. So this is all that you need. Okay, this header file is a very big header file. So I think it's like it's close to 8,000 lines of code. It's a really big header file. It can load all the types of images. It can load PNG, JPEG, can load bitmap, anything like those. So it's a really versatile one. All you have to do is just copy this. You can just click on this button to copy the source code. We're going to be making a new folder in I'll just make it right here. I'll go right click, add new folder. I'll call something like externals. For the whole externals, I'll do add a new folder, call it STB image, and I'll just do add a new item. It's going to be header file, of course. Call it stb image.h, and literally all I'm going to do is I'm going to paste it right here. Okay, boom. See, it has it has 8,000 lines of code. It's a very big file. It may even slow your PC down, so be careful. Here it says do this, so it tells you how to implement this file. So it says define STB image implementation before include this. So let's just do it right now. Add a CPP file, call it stb image.cpp, and just define this, and then we can just include stb image.sc. See, cool. So let me just compile it and see if it works or not. And boom, build succeeded, which means it compiled successfully. Okay, awesome. So we have our image loader sorted out. Now it's time to load the actual textures and do all the stuff from our side using OpenGL and C++. Alright, so if you remember, I believe it's in the second episode, we made a folder called textures here in the resources. So this is where we're going to be putting all our texture, our images here. So what I'll do, I'll just get the logo right now. logo. So I had my logos here. I'll just copy the logo. I'll go to the illus2D game engine folder. I'll go to this file here. I go to res. I go to textures and literally copy and paste it here. See, so there we have our logo. I'll probably just rename it to like logo. Okay, cool. I believe it's a PNG file. I'm not too sure. Yeah, it's a PNG file. Tab file png.png. Make sure you know the extension of your file. What is okay? So it's a PNG file. If I just refresh it, I can see the texture has been loaded. .png. If you want, you can just do include in project. You can. It's not a big deal because it will, of course, images won't get compiled. Only the .cpp files are the ones that get compiled. Okay, awesome. So let's just get into writing this texture class. So under graphics and not under data buffer, just under graphics, I'll do right click, I'll do add, I'll do a new item. It's gonna be a texture, so we'll do texture.h, and we'll subsequently do a we'll do a cpp file, so we'll do texture.cpp. Awesome. Under texture.h, we're just gonna make a class for textures. That's how, I guess everyone knows that's how we do with every single OpenGL object. We just make a class. Okay, private, public, private. So what is the texture now? First we need to load a texture. So just like with shaders, what we did was we loaded the shader code using a file path. Okay, so we'll do the same thing. We'll do the texture using a file path. So we'll have to include some things here. We'll have to include we'll include the string class, so we can do string file path. Okay, it's gonna be our file path, and we're gonna have the actual buffer to store the texture data. So an actual buffer to store the RGBA pixel values of the texture. So it will be an unsigned char pointer. It's gonna be a pointer of character arrays, and we'll just call it something like p underscore texture data. Okay, cool. So we have the file path and we have the texture data, and we'll probably also have some variables here as well. So we'll have something like a int width of the texture, height of the texture, and something like the bits per pixel. So like how many channels, like if it has a RGBA value only, or if it has like RGBA with alpha as well. So we'll just call it channels. Okay, that's known as channel. So RGB or RGBA. Cool. We have that. Yeah, so let's just get into implement this class. We need a constructor, need a destructor. That we'll of course need a void bind for the texture. It's going to take in a slot, texture slot, unsigned. Oops, I cannot type for some reason. So slot by default is going to be 0. Actually, I'm not gonna put this slot here. I'll not put it as default because I want to do it manually by myself. Right, bind will have of course one for the unbind. It's going to take in a texture slot as well, from which texture slot you want to unbind. That's pretty much it. We'll just go ahead and define this texture class into texture.cpp. Let's do it. Include texture.h constructor for the texture. Oops. Copy, paste, destructor for the texture, bind the texture. It should be const. I think I forgot to do the constant in there. I'll do it right now. Okay, unbind is to be const because they are not going to modify any of our our member variables. So yeah. Okay, let's go load the textures. Of course, what we had to do is it's giving us an error for some reason, because we have to specify the slot. Right, this of course we have to include the STB image, so we'll do include here. We'll include it here. It's from externals, I believe. Yeah, we probably can't use it right now. So maths files, some files, externals. Yeah, basically I'll have to include this path right here. Right click, properties, and we'll do C++. General, we'll have to do it from the project directory, I guess. So this will include directories, we'll have to do project directory, and this should work. Yeah, externals, so the stb image it is. Okay, cool. That's basically it. Go to texture.cpp and kind of it's giving us an error again. Type qualifier not allowed to. Yeah, of course. But do the texture. Great. Alright, so let's begin making our texture. Of course, we forgot to make an ID for the actual texture. That's kind of embarrassing. Do p texture ID. Of course, need a texture ID. Alright, let's go texture.cpp. Let's make the texture, shall we? We'll have to include glue as well. Include gl/glue.h. Alright, that should be enough. Okay, gl gen. Oops. So okay, let's begin making the texture. So gl gen textures. We'll generate one texture at the texture ID. So p underscore texture ID. Not texture data, texture ID. gl bind texture. We're gonna bind it to the gl texture 2D because it's a two-dimensional texture. 2D. Let's bind the p underscore texture ID texture to this binding point. And then what we can do is we can actually send the data to the texture. Now, before we send the actual texture data to this texture object right here, the p underscore texture ID, we have to set up something. So we have to set up the texture properties, kind of. Okay, so I'll just write the code and then I'll explain it as I go. Okay, so to set up the texture properties, we'll go gl text parameter I. See, it's right there. Target. So which texture do you want to set? Do you want me to set the parameter for? So we want to set the parameter for the texture that's currently bound to the gl texture 2D binding point. Okay, so we'll do gl texture 2D, paste it here. Parameter name, so it's going to be geo texture wrap s in the so srt are basically just they're like xyz for texture. That's basically what it is. So in the x direction, we're going to do gl underscore repeat. Okay, copy once. We'll do gl on the s. In the R, I believe it's in the R. Yes, should be yeah. In the R, which is the Y, we're going to do gl repeat as well. So basically, what this means is that if we, for example, this. So if you put a texture up here, I'll put something like this. So let's say this is our 2D surface, and we put a text. We put it. This is our texture. This is our 2D surface, and I'll probably make a texture like this. I'll make a texture right here. I'll fill it with something like this. Okay, so this is our texture. This is our 2D surface. Now, the way OpenGL maps the 2D surface into our texture is it. So the way OpenGL maps the texture to our 2D surface is all it does is it. There's kind of there's something known as texture coordinates. So this the lower left corner is texture coordinate 0 0. This corner is 1 in the x, 0 in the y. This is 1 1. This is 0 1. So these are like the local texture coordinates. So the way it maps to this is you specify a texture coordinate in your vertex buffer with the position. So we'll just map it here. It's gonna map it here. It's gonna map here. It's gonna map 1 1 here. Okay, that's basically it. All right. Now, since it maps like this, what we can do is we can actually specify. We can make it double. So again, instead of doing 1 1, we can do 2 2. Okay. So what that's gonna do is, since we have this gl repeat, it's just gonna put this texture here, right? It's gonna fill it, and it's gonna repeat it. So repeat here in the S and in the R as well. Repeat it. Okay, it's gonna repeat. Now there are some other parameters as well. There's something known as GL clamp. Okay, so GL clamp, basically what it does is just clamps up here. It does not let anything go. Okay, it just clamps right here. And we can specify a border color, what do you want this color to be, and stuff like this. But for now we'll just go for GL, repeat that basically. Okay, so the next one is GL text parameter I. So the GL texture 2D binding point. Binding point is the parameter name, so it's going to be GL texture mag filter. So so what if the object of this for the texture is big? Okay, so if our texture is small, but the object that we're placing the texture onto is big, okay, it's way too big. So what do we do in that case? Well, what we do is we do GL underscore linear. Okay, so we just linearly interpolate the pixels and we just kind of make it work. That's basically what this means. Okay, copy this for the minification filter. So we are going to be using something known as mip maps. So we'll do min filter is going to be GL linear mip map nearest. Okay, cool. That's basically it. So these are our our texture. These are like our texture properties. That's basically it. Okay. Now let's send the data. Now a mip map is just like a smaller version of the textures. So like if the object that we were applying the texture into is actually a lot smaller than the actual texture itself, then we can use the mip maps and apply the mip map texture into the smaller texture, because at the end of the day all a mip map is that it is just a smaller version of the textures. Like I can show you right here as well. If I just go to here, mip maps, for the images, you will see something like these. Yeah, see, so mip maps is like just the smaller version of the texture. So this is the original texture, this is the first mip map, the second mip map, and stuff like this. Okay, cool. That's basically what a mip map is. All right, so let's send the texture data. So to send the data, we'll do first we have to load the texture. Okay, so we had to create this texture data chart pointer. Let's just load the data into it first. All right, I'll probably do something. I'll probably do it here. I'll probably just load the texture image first. So we'll do p underscore texture data equals to stb. I think stbi underscore load. It's going to take in a file name. So the file path, we'll do file path. I believe I have a file path. So the width and the height. So p underscore width, and the address of p underscore height. Channels, so we'll do p underscore channels, channel function. Desired channels is 4, and RGB, and we want the alpha value as well. Okay, cool. Of course I have to take it from the constructor, so we'll do something like illus2D string texture path. P underscore file path, we'll do texture path, and I believe file path P underscore file path to be a texture path, and it's giving me an error for some reason. Okay, the C string. Copy this, paste it here in the constructor. P underscore path to be the file path, and for some reason, I know the reason, it's probably because of this. So this, I've been writing this so wrong. Okay, we're missing everything. Okay, cool. So file path and file path. All right. Within the height, the channel. So we have loaded the textures correctly, hopefully. Let's just check it. So if not texture, if p underscore texture data equals to null pointer, like std cout or std cout failed to load texture data. This hide and we'll of course have to set up this stuff here. Right, so texture ID, p underscore texture ID, we'll set it to 0. Okay, then we'll have include item stream here. Then we have the file path, so we set the value here. So texture data, we'll have to set the null pointer. Data null pointer, the height, the width, height, and the channel. So we'll do p underscore width 0, p underscore height to be 0, p underscore channels to be 0. Okay, cool. So that's basically it. Awesome. So if a picture, failed to load texture data, and we're just gonna. No, we're not gonna do anything. Okay, return. Don't do anything here. Don't load the texture into the VRAM because there's nothing to load because it didn't fail to load first place. Okay, cool. Let's just load the texture now. So geo text image till text image 2D. Load the texture to the texture that's currently bound to the geo texture 2D binding point. The texture level is going to be 0 again. It's like the map level things should start from 0. Internal format. So what's the format from so what format do you want it to be stored internally by OpenGL? So we'll do geo RGBA. The width of the texture is basically the width, so we'll do width. So, p underscore width the texture, height of the texture, p underscore height of the texture. Oops, okay, I was checking my keyboard right there. P underscore height the border. I'm just gonna put no border for now. Format also GL RGBA. Enum type. Now this is. Now this thing right here is it's kind of weird. I said the OpenGL API is a bit weird. So like I said, there's a documentation for OpenGL. It's called docs.gl. So you guys can just go ahead and see. Like I think I mentioned about docs.gl in my shaders video. So if we go docs.gl, go gl text image 2D. So this like the OpenGL API is a bit weird. So if you just wanna like look at like what these like what this type even means, you can just take a look at this here. Just search for the function, so gl text image 2D, and just look at the function from here. But the type is probably like the type of the data, so it's an unsigned chart. So gl, so it's in gl enum, so we'll do gl unsigned byte for char, and the pixel data is going to be p underscore texture data actual buffer. Okay, cool. That's pretty much it. So we set the texture data, and now we're gonna check if, and after we send the data down, we can just delete the data from our CPU. So we'll do stb free image free from the p underscore texture data. Awesome. That's pretty much it. We'll go to the destructor. So what we'll do here is we'll do gl delete textures. So we'll do 1 and the address of p underscore texture ID. Okay, cool. So bind the binding the texture. So binding the texture, we can bind the textures to different texture slots. There's like, I think for PCs they have like 32 different texture slots. Yes, they can bind a lot of textures at once, and you can use a lot of textures at once in your shader. So it's pretty awesome. So to bind the texture is pretty simple. We do gl bind texture unit. Texture unit will bind the unit for the slot number. The texture is just going to be p underscore the ID of the texture. So what texture you want to bind? Okay, cool. So bind that, and we're going to unbind the texture from slot from the given slot. So slot geo unbind texture unit. Whoa, there's like none for the texture unit bind. Okay, so for unbind, we'll probably have to do something like geo active texture. This is gonna be like geo texture 0 plus the texture slot. We'll do geo bind texture, so we're gonna bind the texture that's currently bound to geo texture to the binding point, and we want to bind 0. Don't want to bind anything at all. Okay, cool. That's pretty much it. Just so this works. So we bind the texture to the slot, and we unbind it by just activating the texture slot and unbinding everything that was done. Okay, cool. This is our texture class. This is our basic texture class. I hope it works. Just check it right here. Will include graphics/texture.h, and let's just check the textures here. So get rid of this textures model. I'll get rid of this as well. I'll get rid of all of these, to be honest. Model matrix, you also gonna go shader, vertex shader, fragment shader. Get rid of that, get rid of that. Okay. Texture, okay, so let's load the texture. Texture. Now also I forgot to put in namespace, as I already do. So namespace, illus2D. Namespace, graphics. I always forget to put these in the namespace. It's pretty awesome. I always forget to do this. So we'll do namespace again. We'll copy this literally, paste it here. Bam. I love Visual Studio for that. Visual Studio automates a lot of stuff. It's pretty convenient. Right, vertex shader. Let's just set up a texture coordinate. So let's just run the code for now. See if it works. Compile everything. Generate the code. Link it successfully. Okay, we have this yellow triangle. To compile it, what we'll do, to just check it, what we'll do is we'll go over here. So we load the texture 1 uploads the file path, so it's going to be res textures logo.png, and let's just check if our texture was loaded or not, because we can tell it from the thing. So yeah, so our texture did load. And how did you know? Is that because in the constructor we had a checking system for the texture. We checked it, so if it was null pointer, it filled the texture, but didn't. So obviously our texture loaded. Okay, cool, awesome. So we'll bind texture 1 to the binding point slot 0. Okay, we'll bind to that texture slot. I guess I forgot to do this. So for unbind, you can just copy this. We can just slot 0. No slot 0. We can slot for slot. We can bind 0. No texture. That's pretty much it. Okay, cool. CVP texture to bind the texture to textures to slot 0. Now in the vertex, now obviously have to define the texture coordinates. So we'll do something. So we'll define it here. So the bottom left is going to be the bottom left of the texture. The bottom right is going to be the bottom right of the texture. So 1 in the x, 0 in the y. The middle top, the pointy edge, the top pointy edge is going to be 5 in the x, 0.5 in the y. Okay, cool. That's pretty much it. We'll have to set the layout as well. So copy it, just paste it once. So we can just do I guess it's layout dot push data layout. It's pretty simple. Push in to geo flow. That's pretty much it. Okay, so push the layout and set the layout, index buffer, everything's gonna say the same. Vertex buffer is gonna say the same, of course. And yep, that's pretty much it. Now let's just accept our thing in the fragment shader. In vec2 is gonna be text coordinate. We'll put this text coordinate to the fragment shader so it can interpolate between the texture and the texture coordinate. So out can be vector2 v underscore text chord, v underscore text chord is going to take the text chord. We're going to accept the in vec2 v underscore text chord, and the color is going to be a so we need a way to take the texture unit. Okay, so for the texture unit we have a separate data type. We call it something known as a sampler. So we'll do from here. So uniform sampler 2D u underscore texture unit, and the color is going to be a special function called texture function. So texture is going to take in the texture unit first, and then it's going to take the coordinate of the texture. Okay, cool. It's texture unit and the coordinate of the texture. Alright, so let's just pass this data. So we pass the data here. Set the uniform, so we'll do shader dot set uniform 1i, the u underscore texture unit. We'll set it to the texture unit 0 because we bound our texture to texture slot 0. Okay. Let's run the code. Hopefully no errors. I'm pretty sure we made some error in the syntax. Yep, we get nothing. Of course, there's something wrong with our API. Yep. So okay, so our textures work, of course. Damn, that took some time. That took a lot of time to debug. The error was not the texture. Our error was not the texture class, but instead our error was the API, our thing here. So if I go to the vertex buffer layout, the vertex array, so I got the vertex array, I can see here vertex array h. Right, so vertex push layout, which is indices, vertex recap per count, which is the data count. So if offset off 0, return the offset. So we forgot to multiply here with the size of the float. Okay, that's alright. Forgot to multiply the size of the float in here. I'll get that offset size of floats, which means here now this should work. So we'll make a vertex buffer object. So vertex array, hold on, we have a vertex array. Yeah, we do have a vertex array. We'll do vertex VB layout to geofloat layout. We'll do layout dot push data layout dot set layout. Cool. So that was the issue. Our issue was not the texture class, but our so it works. So our issue was the vertex buffer layout, which was sending out the wrong texture coordinates. Okay, cool. That works. That works fine. Yeah, that's basically it. We can see our texture here. Yep. So that's pretty much it with the texture. Let me get back to the code here. Yeah, that's our texture class. Yeah, this is a pretty long stream. I'll probably trim the stream. I'll trim it, so I'll just include the correct stuff. And yeah, I'll just next video is going to be a maintenance code, code maintenance episode. We're gonna check into that. Okay.